So you are going to break down some radicals today, which you've done in geometry and algebra 1. But the first step is making a factor tree. So like for 72, you could pick any two numbers that multiply to get you 72. I'm going to do 9 and 8. And then break those down into their factors. And when you get down to your prime numbers, your prime factorization is all those prime factors multiplied together. So it could look like 3 times 3 times 2 times 2 times 2, or 3 squared times 2 to the third. So if we're going to simplify our radicals, to have a radical be completely simplified, it can't have any factors inside your radicand that have a perfect square factor. And there can't be any radicals in your denominator. So for example, if you have the square root of 25 times 2, 25 is a perfect square, so you'd need to go ahead and take its square root and then just turn it into 5 times the square root of 2. So let's break down some radicals. Okay, let's start with square root of 75. We're going to simplify each one and give the exact value, so no decimals, no punched in a calculator. Make your factor tree for 75. It breaks down into 5 times 5 times 3. And then if you think about what a square root is asking, it's asking what number is being taken times itself. So you have 5 squared, or 5 being taken times itself, and if you're doing the square root of that, that would just give you 5, just plain old 5, not inside your radical. Square root of 5 squared, or square root of 25 is 5. And then you have your 3 that was not being squared or taken times itself, so it's still trapped inside your radical. If you have two radicals being multiplied, easiest way to do it is to don't break them down or anything first, just rewrite it as those two factors multiplied inside one radical, and then break them down. So 6 is 3 times 2, 21 is 3 times 7. If you look at it, now you do have 3 being multiplied times itself, so square root of any factor times itself is just that original number, so I can bring that 3 to the outside, and then 2 times 7 is trapped inside, 3 times square root of 14. This next one, we have some values being multiplied outside a radical. So 2 and 3 are on the outside. They're kind of in their own little world compared to the inside. So let's go ahead and multiply them and turn them into 6. And then 8 times 28 is inside my radical. If I break each of those down, no reason to multiply 8 times 28 and make it into like 200 or whatever that is. Just leave it 8 times 28 and break those down individually. So if you break those down into their prime factors, it looks like that. And then for every 2 that's being taken times itself, you can take its square root and have a 2 on the outside. So square root of 2 squared gives you 2, square root of another 2 squared gives you 2. And then on the inside, you still have 2 and 7. Don't forget the 6 that was on the outside. So if you multiply 6 times 2 times 2, you get 24, and then square root of 14.